Looking at the problem, we have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. These numbers are going to add up to 28. You can add them in any order you choose. Let's just go left to right, prove to ourselves this works. So we add 1 and 2. We're going to get 3. 3 and 3 is going to give us 6. 6 and 4 is going to give us 10. 10 plus 5 is 15. 15 and 6 is 21. And to finish it off, 21 and 7, final answer. I'm going to put that to the right of the equal sign. Maybe even put a box around it so I'm clear what's my final answer versus some of the work, some of the intermediate steps that I've shown. We're looking at problem B. Note the parentheses. So we got the parentheses means the quantity, 1 plus 2 plus 3. And to that, we're going to add the quantity, 4 plus 5 plus 6 plus 7. So again, you can add the same numbers in any order for addition. Basically, you can ignore the parentheses. So one way to do the problem, just ignore the parentheses. Notice it's the same as the first problem. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 is going to add to 28, just like it did a moment ago. If you'd like to see how the parentheses work, we'll notice that we have 1 plus 2 plus 3 is 6. And we're going to add to that the quantity 4 plus 5 plus 6 plus 7. So 4 and 5 is 9. 9 and 6 is 15. And 15 and 7 is 22. So we're going to be ultimately adding 6 plus 22. Again, the answer is 28. And just to distinguish my answer from the work, I'm going to put a box around it. Got the same thing happening in problem C, right? The parentheses don't matter. Normally in algebra we would do the parentheses first, but there's a shortcut here, right? We're just adding the numbers 1 through 7. Again, the answer is going to be 28. If you want to prove this to yourself, you get 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. So we're going to be adding 15. And 6 plus 7, which is 13. 15 plus 13, again, 28. On the third problem, same numbers. The answer is going to be 28. Let's prove it to ourselves. 1 plus 2 is 3. 3 is just 3, not in parentheses. 4 plus 5 plus 6 plus 7. Let's tally it up. 4 plus 5 is 9. 9 plus 6 is 15. 15 and 7 is 22. So we got 22 plus 3 is 25 plus another 3, again 28. Now in problem E, we got the same numbers in the reverse order. 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. The answer is going to be 28. We're just adding the numbers 1 to 7. Happens to be a different order. Essentially, we're kind of going right to left instead of left to right relative to problem A. But again, let's prove it out. 6 and 7 is going to give us 13. 13 and 5 is going to give us 18. 18 and 4 is going to give us 22. 22 and 3 is going to give us 25. 25 and 2 is going to give us 27. 27 plus 1 is 28. Final answer, it goes to the right of the equal sign. I'm going to put a box around it. More parentheses on problem F. 7 plus 6 is 13. 13 and 5 is 18. 18 and 4 is 22. So we have the quantity 22 in the parentheses, plus 3 plus 2 plus 1. 22 and 3 is 25. 25 plus 2 is 27. 27 and 1, again, 28. Final answer. Now, looks like a trick problem. 4 plus 1 plus 2 plus 7 plus 3 plus 5 plus 6. Oh my. Is this the same problem or a different problem? Let's take a moment to tally. Notice we've got 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. And notice I've counted all the numbers once, just taking care to note that it's really the same thing. It's the numbers 1 through 7 added up. It's going to be the same as it's been, 28. And I'm not going to take the time to prove it out on this one. You can if you like. So keep in mind I'm showing a lot of extra work here just to prove to you that the numbers 1 to 7 always add up to 28. A really good way to do the problem is to make the calculation on the first one, maybe check your work, recognize that these are all the same, and you can just write down the answer 28 because the associative and commutative properties of addition guarantee that we can always add these same numbers in any order, any parentheses, it doesn't matter. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 is always going to be 28. The order of addition is irrelevant.